Hello, in this lecture we will find the size of line segment AE. In the drawing we have square ABCD. We know that BE equals to 2 units, DE equals to 8 units, and we want to find out the size of line segment AE. Actually, the size of this line segment. Okay, so first of all we will join points B and D together by a straight line. We also know it is given us in the question that this angle DEB equals to 90 degrees. It is a right angle, therefore triangle DEB is a right triangle. So I write it down. Triangle DEB is a right triangle. So triangle DEB is a right triangle, therefore we can implement the Pythagoras theorem in the right triangle, triangle DEB. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, DB is the hypotenuse, therefore DB square equals to EB square plus DE square. Okay, according to the Pythagoras theorem, in the right triangle, triangle DEB, DB square equals to EB square plus DE square. So DB square equals to EB square. EB equals to 2, so 2 square is 4 plus DE square. DE equals to 8, so 8 square is 64. So in total we got that DB square equals to 64 plus 4, that is 68, so I will write it down. We found out that DB square equals to 68. Here we will take a root out of question number 1 and we will get that DB equals to the square root of 68. Okay, we found out that DB equals to the square root of 68, so I will write here that DB equals to the square root of 68. And we also know that all the angles inside the square are right angles, therefore angle BDC is a right angle, it equals to 90 degrees. Therefore, triangle DBC is a right angle So if you focus, so triangle DBC is a right triangle, and we also have a rule. I will present to you new rule, rule number 1. According to rule number 1, the diagonals of a square cross the angles of the square into 45 degrees angles. So according to rule number 1, the diagonals of a square cross the angles of the square into 45 degrees angles. So actually line segment DB is the diagonal of square ABCD, and according to rule number 1, the diagonal DB creates angle of 45 degrees. It crosses the angle, this angle that equals to 90 degrees, it crosses it to angle of 45 degrees, so this angle will be equal to 45 degrees according to rule number 1. Angle BDC will be equal to 45 degrees, and also angle DBC will be also equal to 45 degrees because of the fact that the diagonal DB crosses the right angles of a square into two equal parts. That is to say, this angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees. Okay, so now we will focus on the right triangle, triangle DBC. So in triangle DBC, this right triangle cosinus 45 degrees equals to DC over DB. Okay, the right triangle DBC cosinus 45 degrees equals to DC over DB. So we will define DC as y, that is to say DC equals to y, according to our definition. So cosinus 45 degrees is root 2 over 2, or square root of 2 over 2, and it equals to DC. DC is defined as y over dB. We have already found out that dB equals to the square root of 68. Okay, we got that root 2 over 2, that is cosinus 45 degrees, equals to y over square root of 68. Here we will multiply equation number 2 by square root of 48, and we will get that y equals to square root of 68 times square root of 2 over 2. Okay, I found out that y equals to square root of 68 times square root of 2 over 2. Okay, we know that 68 is 34 times 2, so I write it down. So y equals to 68 is 34 times 2 times square root of 2 over 2 and we know that square root of AB equals to square root of A times square root of B. Therefore, square root of 34 times 2 equals to square root of 34 times square root of 2 times square root of 2 over 2, and it equals to y according to equation number 2. So square root of 2 times square root of 2 is 2. So I write it down that y equals to square root of 34. Again, square root of 2 times square root of 2 is 2 over 2. Okay, so we found out that y equals to, according to equation number 2, y equals to square root of 34 times 2 over 2. 2 over 2 is 1, so 2 will get cancelled. And we actually found out that y equals to square root of 34 y equals to square root of 34 so all the sides of a square are equal to each other, therefore AB equals to BC equals to DC equals to DA equals to square root of 34. So I write it down. DC equals to square root of 34 and BC also equals to square root of 34 and AB equals to square root of 34 and AD also equals to square root of 34. Okay, so in the next step I will present to you a new rule number 2. Actually, rule number 2 states that before that we know that all the sides of the angles inside the square are right angles, therefore angle BAD equals to 90 degrees. It is a right angle. And we also know it is given us in the question that angle DEB also is a right angle, it equals to 90 degrees. So now I will present to you rule number 2. Rule number 2 states that if a line segment AB subtends two equal angles on the same side, then quadrilateral ABCD is inscribed by a circle and the 4 points A, B, C, and D lie on that circle. So I will read rule number 2 again. Rule number 2 states that if a line segment AB subtends two equal angles on the same side, then quadrilateral ABCD is inscribed by a circle and the 4 points A, B, C, and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and even before that, suppose that we have here a blanket page, and now I will draw line segment AB. Suppose that we don't have this blue circle, but just line segment AB. So line segment AB in the red color, and this line segment AB subtends two equal angles. So the first angle will be theta. Angle ACB that is equal to theta subtend on line segment AB, and we have also another angle that equals to theta that subtends on the same line segment AB. So we have the second line segment and the second angle that equals to theta. So angle ADB also equals to theta, and angle ADB also subtend on the same segment line AB, line segment AB. Okay, so if we have two equal angles that subtend on the same line segment AB, then the quadrilateral, according to rule number 2, the quadrilateral ABCD, this quadrilateral is inscribed by a circle. So only if we have two angles that are equal to each other and they subtend on the same segment line AB, only then we can conclude that according to rule number 2, the quadrilateral ABCD is inscribed by this blue circle, and the 4 points A, B, C, and D lie on this blue circle. Okay? So this is true according to rule number 2. Whenever we have two equal angles that subtend on the same segment line AB in this example, then the quadrilateral ABCD is inscribed by this blue circle, and the 4 points A, B, C, and D lie on this blue circle. Okay? We can implement rule number 2 in our drawing, because in our drawing we have two right angles that subtend on the same segment line BD. I write it down. In our drawing we have two right angles that subtend on the same segment line DB. So I write it down. Angle BAD equals to 90 degrees, this angle, and angle DAB subtend on line segment BD. And we also have angle DEB, this right angle that equals to 90 degrees, and it also subtends on the same segment line BD. Okay, so we actually have two right angles that subtend on the same segment line BD. Therefore, according to rule number 2, quadrilateral AEBD, the quadrilateral in the green color, is inscribed by a circle. The green quadrilateral AEBD is inscribed by a circle, and the 4 points AEBD lie on that circle. So I will draw it. So we have quadrilateral, according to rule number 2, quadrilateral AEBD, quadrilateral AEBD is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. This is true according to rule number 2. According to rule number 2, and it is true because of the fact that we have two right angles that subtend on the same segment line BD. Therefore, the quadrilateral AEBD in the green color is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. So I will draw the quadrilateral, the green quadrilateral inside this circle. Quadrilateral AE BD quadrilateral A, E, P, D. This quadrilateral is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this circle. As you can see it, all 4 points lie on this circle. This is true according to rule number 2. So we also have rule number 3. According to rule number 3, if quadrilateral ABCD is inscribed by a circle, quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So I will read rule number 3 again according to rule number 3. If quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 3? The meaning of rule number 3 is that if you have this circle and inside this circle we have quadrilateral ABCD. Okay, quadrilateral ABCD is inscribed by this blue circle. So this is quadrilateral ABCD. We know that side AB of quadrilateral ABCD equals to A units. Side BC of quadrilateral ABCD equals to B units in its size. Side CD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. And this quadrilateral ABCD has two diagonals. Diagonal AC we will define diagonal AC as X, that is to say AC equals to X units in its size, and quadrilateral ABCD has also second diagonal, diagonal DB, and diagonal DB equals to Y units in its size. So if we have quadrilateral ABCD that is inscribed by a circle, then according to rule number 3, the product of its diagonals, that is to say X times Y, equals to the sum of the products of its opposite sides. Actually, quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides is side BD, side BC. This side is opposite to side AD, and the product of those two opposite sides, it is actually B times D. And we also have the second pair of opposite sides in quadrilateral ABCD. Side AB is opposite to side CD, and the product of those two opposite sides, it is actually A times C. And according to rule number 3, the sum of the product of its opposite sides, that is to say BD plus AC, equals to the product of its diagonals, that is to say x times y. Again, the product of its diagonals, that is x times y, equals to the sum of the products of its opposite sides, that is actually BD plus AC. Okay? So that is rule number 3, and we actually can implement rule number 3 in our drawing. Okay? We will implement rule number 3 in our drawing, because in our drawing we have quadrilateral AEBD. It is inscribed by this blue circle according to rule number 2, and the 4 points A, E, B, and D lie on this blue circle. Okay, so we arrive to this drawing it is true according to rule number 2, because of the fact that two angles subtend, those two right angles subtend on the same segment line BD. So actually those two angles, this angle is a right angle and it subtends on line segment BD, and we also have the second angle DEB, that subtends on the same, that is a right angle that subtends on the same line segment DB. Therefore, according to rule number 2, the quadrilateral AEBD is inscribed by this blue circle, and the quadrilateral AEBD is inscribed by this blue circle, and all 4 points AEBD lie on this blue circle. So this drawing is true according to rule number 2, and now we will implement rule number 3 in our drawing. Actually, quadrilateral AEBD has two diagonals. The first diagonal is diagonal DE, and the second diagonal is diagonal AB. Diagonal AB is the second diagonal, and so we have quadrilateral AEBD that is inscribed by this circle. Therefore, according to rule number 3, the product of its diagonals, that is actually AB times DE, AB times DE, the product of its diagonals, equals to the sum of the products of its opposite sides. And the sum of the product, so AB times DE, that is the product of its diagonals, the product of quadrilateral AEBD diagonals is AB times DE. and this product equals to the sum of the products. This product equals to the sum of the products of its opposite sides, and the first sum of the products of its opposite sides is AE times BD. AE times BD. And the second product of its opposite sides is AD times EB. And the sum of the products of its diagonals, it is AE times BD plus AD times EB. So according to rule number 3, because of the fact that quadrilateral AEBD is inscribed by this circle, and this quadrilateral AEBD is inscribed by this circle according to rule number 2. So, because of the fact that quadrilateral AEBD is inscribed by this circle, then the product of its diagonals, that is actually AB times DE, AB times DE equals to the sum of the products of its opposite sides. The first product of its opposite sides is AE times DB, or AE times BD, and the second product of its opposite sides is AD times EB. AD times EB, and the sum of the products of its opposite sides is the first product plus the second product, and the sum of the product, it is the sum of those two products together, and it equals to the sum of the products of its diagonals, that is actually AB times DE. So this equality is the implementation of rule number 3 in our drawing. So this will be question number 3, and it is the implementation of rule number 3 in our drawing. Okay, so the only thing that is left to do is to put the data inside this equation number 3 in order to find out the value of AE. AE is the line segment that we are looking for. So we will put the data inside this equality, and we will get that AB equals to square root of 34 DE equals to 8 units, okay, AB equals to square root of 34, DE equals to 8 units, and all equals to AE. AE is the missing variable, so we will leave it as it is. AE times BD, BD equals to square root of 68, plus AD. What is the size of AD? AD equals to square root of 34 times EB. EB equals to 2 units. It is given us the question. So after we put the data inside equation number 3, we got this equality, and the only missing variable in this equation number 3 is AE. Okay, so here we will substitute 68 by 34 times 2. 68 equals to 34 times 2, so we'll substitute the root of 68 by the root of 34 times 2, and we will get that the square root of 34 times 8 equals to AE, and instead of 68 we will write down 34 times 2 plus square root of 34 times 2. So here we will split the root into two roots according to the rule that the square root of AB equals to square root of A times square root of B. We will get that the square root of 34 times 2 equals to the square root of 34 times square root of 2 times AE plus square root of 34 times 2, and it equals to 8 times the square root of 34. So here we will divide the equation number 3 by square root of 34. So square root of 34 will get cancelled. And what is left after we cancelled square root of 34? What is left is actually in this side of equation number 4 we have 8 equals to root 2 times AE plus 2. Okay, so actually that is what is left after we cancelled the square root of 34. Here we will subtract from equation number 3 2, and we will get that 8 minus 2 is 6, so 6 equals to square root of 2 times AE we will divide this equation number 3 by square root of 2, and we will get that AE equals to 6 over square root of 2 but we know that 6 is 3 times 2, so I'll write it down. So AE equals to 3 times 2 over square root of 2. So here we will multiply this side of equation number 3 by square root of 2, and then we will divide it by square root of 2. So we change nothing. AE equals to 3 times 2 over square root of 2. So we will multiply this expression by square root of 2, and then we will divide it by square root of 2. So what we have in equation number 3, AE equals to 3 times 2 times square root of 2, and square root of 2 times square root of 2 is 2. So we got this expression. So here 2 over 2 is 1, so 2 will get cancelled. And we found out that AE equals to 3 times square root of 2 units. We found out that AE equals to 3 times square root of 2 units. Okay, so the answer to the question is that line segment AE, this line segment, equals to 3 times square root of 2 units, or in terms of numbers, line segment AE will be equal to 3.243. 4 point AE will be equal to 4.243 units. So I will repeat again on the answer to the question. The answer to the question is that line segment AE equals to either 3 times square root of 2 units, or in terms of numbers, line segment AE equals to 4.243 units. Okay, that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the value of line segment AE, or the size of line segment AE. We have here square ABCD. We know that EB equals to 2 units, DE equals to 8 units, and this angle DEB is a right angle, it equals to 90 degrees, and we want to find out the size of angle and the size of line segment AE, or the value of line segment AE. Okay. So the first thing that we did is we joined points D and B by straight line, and actually triangle DEB, this triangle is a right triangle because it has one angle that equals to 90 degrees, so triangle DEB is a right triangle, and we can implement the Pythagoras theorem in the right triangle DEB. According to the Pythagoras theorem in the right triangle DEB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, DB square equals to EB square plus DE square. Okay, so DB square equals to EB square. EB equals to 2 units, so EB square is 4. And DE equals to 8 units, so DE square is 8 square is 64. So we found out that DB square equals to 4 plus 64, that is 68. So DB square equals to 68. Here we took out a root of equation number 1, and we got that DB equals to the square root of 68. Okay, so this actually, this DB, that is also the diagonal of square ABCD, equals to square root of 68. Okay, then I present to you rule number 1. According to rule number 1, the diagonals of a square force the angles of the square into 45 degrees. Actually, the meaning of rule number one is that the diagonals of a square divides the angles of the square into two equal parts. Okay, so therefore this angle will be equal to 45 degrees and this angle will be also equal to 45 degrees according to rule 1. So we know that all the angles inside the square are right angles, therefore this angle is right angle, therefore triangle DBC, this triangle is a right triangle, and in the right triangle DBC, this right triangle, we know that cosinus 45 degrees equals to DC over DB. Okay, cosinus 45 degrees equals to DC over DB. We define DC as Y, therefore, and we also know that cosinus 45 degrees equals to square root of 2 over 2, and DC is Y according to our definition. So we got that square root of 2 over 2 equals to Y over square root of 68. We multiplied equation number 2 by square root of 68 and we got that Y equals to square root of 68 times square root of 2 over 2. Okay, we know that 68 is 34 times 2, so we substitute 68 by 34 times 2, and we also know that the square root of a times b equals to the square root of a times square root of b. Therefore, the square root of 34 times 2 will be equal to the square root of 34 times square root of 2 according to this rule. So we got this equality. Y equals to the square root of 34 times square root of 2 times square root of 2 over 2. We know that the square root of 2 times square root of 2 is 2. So in total we got that Y equals to the square root of 34 times 2 over 2. 2 over 2 is 1. So we got that Y, that is the size of one side of square ABCD, equals to square root of 33 units. So we know that all the sides of a square are equal to each other, so all the sides of this square equals to square root of 34 units. Okay? Then I presented to you rule number 2. Rule number 2 says that if a line segment AB subtends two equal angles on the same side, then quadrilateral ABCD is inscribed by a circle and the 4 points A, B, C and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2, assume that this circle is not exist, okay? And we have only line segment AB, and we know that in this line segment AB in the red color, we have two angles that subtend on line segment AB. Therefore, according to rule number 2, because of the fact that two equal angles subtend on the same line segment AB, according to rule number 2, the quadrilateral ABCD is inscribed by this blue circle, and the 4 points A, B, C, and D lie on this blue circle. Okay, so whenever you have two equal angles that subtend on the same segment line, then you can conclude from it that the quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. Okay, that is rule number 2, and we can implement rule number 2 in our drawing, because we have in our drawing two right angles that subtend on the same segment line DB. Angle BAD equals to 90 degrees, and it subtends on segment line or line segment BD, and this angle subtends on the segment line BD and this angle BED also subtend on the same segment line BD. Okay, so therefore we can conclude from it that according to rule number 2, the quadrilateral AEBD is inscribed by this. The quadrilateral in the green color is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. Okay, quadrilateral AEBD is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. Okay, so actually because of the fact that we have here two right angles that subtend on the same segment line BD, we can conclude from it, according to rule number 2, that quadrilateral AEBD is inscribed by this blue circle, and all 4 points A, E, B, and D lie on this blue circle. Okay? Actually, this drawing is the implementation of rule number 2 in our drawing. Okay? So, because of the fact that those two equal angles lie on the same segment line, the quadrilateral AEBD is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay? And we also have rule number 3. According to rule number 3, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So we have quadrilateral ABCD, this quadrilateral that is described by this blue circle. So if we have a quadrilateral that is inscribed by a circle, like in this drawing, we can implement rule number 3 in this thing. Okay, whenever we have a quadrilateral that is inscribed by a circle, we can implement rule number 3. And we have here quadrilateral ABCD that is inscribed by this blue circle, therefore we can implement rule number 3, and according to rule number 3, the product of quadrilateral ABCD diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. And the first product of its opposite sides is B times D, the second product of its opposite sides is A times C, and the sum of the product of its opposite sides is BD plus AC, and that sum of the product of its opposite sides equals to the product of its diagonals, that is actually x times y. Okay, again the product of its diagonals, that is to say x times y, equals to the sum of the product of its opposite sides, that is to say equals to BD plus AC. Okay, and we again can implement rule number 3 in our drawing. Why? Because in our drawing we have quadrilateral AEBD that is inscribed by this blue circle. And the reason that this quadrilateral in the green color is inscribed by a blue circle is because of the fact that we have two right angles that subtend on the same segment line. Therefore, according to rule number 2, quadrilateral AEBD is inscribed by this blue circle, and the 4 points AEBD lie on that circle. So this drawing is true according to rule number 2. Okay? So we have here quadrilateral AEBD that is inscribed by this blue circle. Therefore, we can implement rule number 3 in this drawing. Why? Because we have quadrilateral AEBD that is inscribed by this blue circle. And according to rule number 3, the product of quadrilateral AEBD diagonals, that is to say AB times DE, AB times DE, the product of quadrilateral AEBD diagonals is AB times DE, and this product equals to the sum of the products of its opposite sides. And the sum of the product of its opposite sides, the first product of its opposite sides is AE times BD. AE times BD is the first product of its opposite sides, and the second product of its opposite sides is AD times EB. AD times EB is the second product of its opposite sides, and the sum of the products of its opposite sides is actually those two products together. The sum of those two products together, and the sum of those two products together equals to the product of its diagonals, that is actually AB times DE. So here equation number 3 is the implementation of rule number 3 in our drawing, in this drawing. Okay. Again, the product of its diagonals that is actually AB times DE equals to the sum of the products of its opposite sides, equals to AE times BD plus AD times AB plus AD times EB. Okay, and we know that AB equals to square root of 34. AB equals to square root of 34. DE equals to 8 units. It is given us in the question. AE is the missing variable. BD, we have already found out that BD equals to square root of 68. AD equals to square root of 34. And EB equals to 2 units. It is given us in the question. Okay, so we have all the values of all the variables in the question number 3, and the only missing variable is AE, is the line segment that we are looking for. We want to find out the size of AE. Okay, so here we know that 68 is 34 times 2. And according to the rule that the square root of A times B equals to the square root of A times square root of B, the square root of 34 times 2 equals to the square root of 2 times the square root of 2 times square root of 34. Okay, so we divided equation number 3 by square root of 34, and we got this equality, this equation number 3, that 8 equals to square root of 2 times AE plus 2. Here we subtracted 2 from equation number 3. 8 times 2 is 6, so we got that 6 equals to square root of 2 times AE. We divided equation number 3 by square root of 2, and we got that AE equals to 6 over square root of 2. We know that 6 equals to 3 times 2, so we got that A equals to 3 times 2 over square root of 2. Here we multiplied this expression by square root of 2, and then we divided it by square root of 2. And here, okay, we multiplied it by square root of 2, and then we divided it by square root of 2, so we changed nothing. So here, square root of 2 times square root of 2 is 2. So in total we got that 3 times 2 times square root of 2 over 2 is the size of AE. So 2 over 2 is 1, so 2 will get cancelled, and we got that the size of square root of AE equals to either 3 times square root of 2 units. Again, the size of this line segment AE equals to either 3 times square root of 2 units, or in terms of numbers, the size of square root of the size of AE, the size of line segment AE equals to 3.243 units. Again, the size of line segment AE equals to either 3 times root 2 square units, or in terms of numbers, the size of line segment AE equals to 4.243 units. Okay, those are the two same answers in different representations. Okay, that is the answer to the question. Okay, thank you very much.